How did a small idea turn into something evolutionary in the world of communication? It all starts from the idea that light is a wave that carries information. We know that light is really fast. It can travel with a speed of 3 × 10⁸ meters per second. Light usually travels in straight lines, but when it's traveling in different optical density media, light will bend. This is called refraction. A special case of refraction is called the total internal reflection. It's basically when light goes with an angle of incidence that is greater than the critical angle of the medium. Of course, when light is going from a denser to a rarer medium. So how can the idea of light doing total internal reflection be useful in today's communication world? Let's see the journey of your email. You type your email down and you hit the send button to your friend. What happens next is really awesome. Your device is programmed to convert the letters into binary long language of zeros and ones. These info are then carried by a light wave with different frequencies and wavelength. The ray of light carrying your message enters then the optical fiber cable that will pass the message all the way to your friend's house router Wi-Fi. The router will then send the wave as a signal to your mobile phone. To your friend's mobile phone, the message is then converted back from binary into letters. So in fact, all this magic happens inside these optical fiber cables. Let's have a close look over what is happening inside. So the optical fiber is made out of a core and a cladding. This is the core. Okay, and then it's all wrapped with something called the cladding. Okay, so the core is made out of glass and it has an index of refraction N1. The cladding has an index of refraction of N2. So when light goes inside, it goes with an angle I that is greater than the critical angle. This is why it will do total internal reflection inside. And then the ray of light will keep on bouncing off until it will reach the terminal of the core. In order to obtain total internal reflection, the condition is that N1 should be slightly greater than N2. Okay. So light will start to bounce off the inner surface, undergoing total internal reflection until it will reach the terminal of the wire. And so the idea that light is so fast, it actually kind of explains why the message takes only a fraction of a second to reach us. So your info is traveling through a ray of light, a light wave that is insanely fast. And all of this is in a thin glass core that is actually sometimes thinner than the human hair, called the optical fiber. So optical fibers are thin strands of solid glass about the size of a human hair. They are widely used in not only communication and medicine, lighting, and sensors. We will see this later on. Optical fibers can transmit light signals at high speed over very long distances, and they are used in phone and internet connections. So does it mean that there are cables between the continents of the world? Yes, in fact, that's the map that shows the connection between continents. All the wires that you see, the colored wire that you see right now, are connections deep in the ocean, in the seabed. Okay, so I show you now a video.
Internet in a fraction of a second. The answer lies deep within the ocean. On this episode, we'll take a look at deep sea internet cables. This episode is also sponsored by blaze.com/TTP. While many believe the global internet was made possible by satellites, this simply isn't the case. The internet, believe it or not, is a physical network connected on land and under the ocean. A solution needed to be found how we could connect everyone across the globe. After the invention of fiber optics, this technology soon spread across the world. Fiber optic lines are run from town to town and city to city on land, but when it comes to crossing the ocean, a special cable and ship was needed to pull it. Data is transferred on fiber optics, or these strands of perfect glass with pulses of light. When created, the bidirectional fibers are color-coded, with each color indicating a direction of data flow. Having a cable that lives in the ocean took some specific engineering. First off, the fiber optic strands are the width of a human hair and are coated with gel to keep them in place in this first layer of protection in a plastic tube. Around the plastic tube are steel wires that add needed strength and protection. The next layer is made of copper, which not only adds additional strength, but transfers power to repeaters. Repeaters are these canister-like devices that amplify the light every 50 miles or 80 kilometers, so the signal will make it to the other side of the ocean. The final layer is made of plastic, which insulates the entire package. This is the basic oceanic cable configuration, but cables placed near shallow areas, close to shore, or commercial fishing areas need more protection. 2 additional layers of galvanized steel capped with nylon thread and tar will be added for these areas. These cables are manufactured and spun in giant reels, which go into pans in this large facility. When ships head out to sea, they'll have around 100 pans to finish the job. When it's time to load the ship that'll carry the cables out to sea, a series of conveyor belts called the cable highway pulls the cables into a large spool at the base of the ship's hull. An entire crew working 12-hour shifts for a month is what it'll take to get the ship ready to pull a new internet cable. The ship will make its way to its starting location and get as close as possible to the beach without becoming beached itself. Cable is floated out to shore, then buried in the sand. As the ship starts to leave the coast, a remote-operated plow. This device will bury the cable as the ship moves. Dense, rigid sea floors only require the cable to be buried a small ways underneath. If the floor is soft and gooey, the plow will have to work much harder to embed the cable much lower. Plows like the ROV-6 can perform this work up to 6,500 feet or 2,000 meters below the surface of the ocean. Robotic arms and jets help put the cable into the ground, and treads allow it to traverse on the ocean's floor. These robots are controlled from the comfort of the ship with small-scale replicas. These ships have designated routes already planned where the ocean floor is flat and smooth for easy placement. When crossing places like the Atlantic Ocean, the Atlantic Ridge is an underwater rocky mountain range which requires the cable to be reinforced within that region. Now you might be wondering, do these cables have to be laid in one piece? Can they be repaired if damaged? Do sea life attack these cables? Well, first off, yes, sharks have been known to bite and gnaw on them, but don't typically get through the cables. If they have been damaged, they can be repaired. When laying a new line of cable, commonly there are 2 ships doing this job, one from either side, and they'll meet somewhere in the middle. When they meet, the cables will be fused together, and this is the basics of how we have our internet today. Internet in a
All right, so now that we understand what optical fiber are and how important they are, whom do you think we shall thank? It's all thanks to Narendra Kapani. I don't know if I said his name correct. So he's the man who could introduce the word to the optical fiber after years and years of using copper DSL wires. Though, who took all the credit? It was, I think he's, I don't know his nationality. So Charles Cow in 2009, he took the Nobel Prize for the invention of optical fiber. He did slightly improvements to Kapani's idea. All right, so the evolution of communication, we should be grateful that we're living in this century, as from 1980 all the way to the introduction of the internet in 1960s, till today, optical fiber is widely used not only in communication but in medicine. It is widely used in medicine in order to do complicated surgeries that can now be done easily because of optical fiber. And that's your task. You need to compare optical fiber to copper wires. Everything concerning optical fiber highlighted in yellow, everything concerning copper highlighted in green in terms of these things. Now, I will provide you with 4 resources. I need you to read all of them. You need to show proof in your final PDF paper that you'll submit to the Dropbox. You need to show proof that you used these resources by underlining, highlighting the words. Some of the words are like new. You need to search for their definition, and you should include them by the end of your paper along with the bibliography that can only be links. So you can just give me the links, all right? And this is where your work is mainly. Actually, it's these two. So the comparison should be in a paragraph, and you need to show, this is very important, you need to include the importance of optical fiber and how much we rely on it nowadays in terms of communication mainly. All right? Now, some of you asked me, can we use diagrams or charts to support our comparison or to show extra evidence for anything? Yes, you can. You can, if you have used any other resource other than the 4 resources that I provided you, then you can, you should reference them. You can and you should reference them. So your work is basically only the things that are highlighted in blue. This is what you should get in your final paper that will be submitted to the Dropbox on Sunday. All right?